Everyone. My name is James Lewis, and I'm from NASA Goddard Space Flight Center, and I'm a member of the Sample Analysis at Mars Instrument Suite team. And rather than having to say Sample Analysis at Mars Instrument Suite all the time, we usually just refer to it as SAM. And before I kind of wanted to go into the organic data we've collected on Mars, I wanted to kind of give a brief overview of how the SAM instrument operates. And basically, we start by either drilling or scooping a bit of Mars. We sieve and portion that sample, then we seal it in the SAM oven, and it undergoes thermal processing. And sometimes before thermal processing, we can do this process called derivatization, which is where we react it with various chemicals to make potential organic compounds in the sample more amenable to analysis. Alternatively, we can do combustion experiments, which is where if we want to do like isotope studies, you combust it and just analyze CO2 and species like that. But then the important thing to remember about SAM is it's an instrument suite, not just an instrument. So when we kind of produce these gases in the SAM oven, we can analyze them by a gas chromatograph, by a mass spectrometer, or a laser spectrometer. And this makes SAM an incredibly capable instrument suite. It can do all forms of analyses, and we can adapt it to all sorts of challenges that we face on Mars. And it's also important to remember that SAM is not the first organic detection mission to fly to Mars. With the Viking landers in 1976, they were tasked with trying to identify life and also see if they could find organic compounds on the surface of Mars. But in these experiments, the only species they found, I've shown here, which is kind of just a kind of simple chloromethane species. And at the time, they had no idea where that could be coming from, and they kind of believed it was most likely carried on the spacecraft from Earth-based contamination. But then with the Phoenix lander in 2008, we discovered this salt called perchlorate. And when you kind of heat up a perchlorate, you release chlorine and oxygen. So if you're trying to detect organic compounds and you're releasing chlorine and oxygen at the same time, you can combust or alter your organic compounds, and you lose the information those species would have told you. So with MSL, we kind of knew we would be facing these challenges, but with kind of SAM's enhanced capabilities, we could adapt to them. So one of the first things we analyzed was the rock nest sample, which was kind of a windblown material. And when we heated this sample up, we saw CO2 and O2 evolving at the same time. And that suggested that we could have potential combustion of organic matter happening in the SAM oven. And then the other interesting thing is we saw these chlorinated hydrocarbons that Viking had seen. We saw chloromethane, and we also saw very small amounts of chlorobenzene. The other thing is the perchlorates that Phoenix had seen, with the O2 onset we'd seen in SAM oven, we also saw the evolution of chlorinated organics. And that suggested that the perchlorates we saw in the Phoenix landing site we were also seeing in Gale Crater, and these salts are extremely widespread on the surface of Mars. One other issue we have is that whenever you send a flight instrument to another planet, you're going to come across some issues. And one of the derivatizations we have on board SAM, MTB-STFA, was leaking from one of the samples. But fortunately, we know the kind of pyrolysis products of MTB-STFA extremely well, so we can characterize how much that's impacting our experiments. And then probably the most interesting result in terms of organic matter we've had so far on Mars with MSL is that the Cumberland drill site at Yellowknife Bay, when we kind of analyzed the data that SAM had produced, we saw that the chlorinated hydrocarbons were at significantly higher levels than they had been in rock nest. And one of these species, the chlorobenzene I mentioned earlier, it was at such a high level that basically the carbon in that chlorobenzene couldn't be explained fully by contamination carried from Earth, which means that is evidence that we have organic preservation on the surface of Mars. Because if we can't explain carbon coming completely from Earth, there must be a contribution from the surface of Mars as well. But it's important to remember that that carbon, it could be indigenous to Mars, but it could also be exogenous and originating from interplanetary dust particles or comets or asteroids. But the main thing to take away from that is we know that organic matter is being preserved in some form on the surface of Mars. And we saw further evidence for perchlorates as well. And as Amy mentioned in the previous talk, over the past 5 years, we've done numerous drill sites. And one of the things we keep seeing are multiple CO2 peaks when we heat up these samples. And this could be evidence of organic matter, of carbonates, atmospheric CO2 absorbed onto these materials, or it could be magmatic carbon. But kind of, there's good evidence that we're combusting some form of organic matter, but also there's often been a postulation that on the surface of Mars, you might have these kind of oxidized salts that are formed by the harsh oxidizing environment on the surface of Mars. And when you kind of heat those up, you can release CO2 as well. And then one other thing we've been investigating is that if minerals can trap organic compounds and release them at high temperatures, So one species, such as magnesium sulfate, doesn't break down until 800. And that's above the temperature window that perchlorates are breaking down. So we're particularly interested to see if species such as magnesium sulfate can trap organic matter and kind of release it at a temperature where we get more diagnostic information. And that's where we are so far. And currently, I think we're around Sol 1900. And we're currently on Vera Rubin Ridge, where the hematite unit is. And we'll soon be heading into a clay unit and a sulfate unit. And there could be all sorts of interesting organic preservation in these as well. So stay tuned.